Hello, everyone. Welcome to the live stream. Just gonna get my screen shared here. Okay, good to go. All right, if you're just coming in, let me know if you're here. And if you have any questions from last week, this is a continuation of the ARM rig that we're building using USD Scale. We're writing a Python script that will build out this ARM. And if you didn't see last week, all we're doing is we're taking the example from over here from the USD documentation, scaling an ARM. There's a USDA file that kind of shows you what the data should look like, how it should be encoded for a basic ARM. And we can go ahead and open that up in USD View. I'm going back to USD 23.2. Because of that, we found an issue trying to play the animation on 23.8. But I did log an issue and I got an answer back. And at the end of this, we'll see if we can apply the fix to this so that we can get it playing in 23.8. All right. Any questions before we get started? Okay. So I will keep this up. I'm going to open extension projects, office hour. Nope, not office hours. Code with me, and this is the one that we've built here. Looks the same. Doesn't animate yet, I think. Yeah, we don't have any keyframes yet or time samples. So let's get to it. Here's my USD scale, my test arm. And what did we find out? Another thing that I can show you. Actually, let's look at the issue here. Here we go. So Spiff said there was an effort to make it strict that in the same way that you might have seen that material binding API needs to be set as an applied schema whenever you do a material binding. You also need to have scale binding API wherever you have USD scale properties defined. So let's take a quick look at what that actually looks like here in hours. I need to open up that arm, unfortunately. This is the final arm. And what's the issue here? So we can see here that this scale animation doesn't have, it's on that one? No, it's on this skeleton. So potentially, I think Spiff was saying if you move the animation up to the scale root, it works. But I think if we put this applied schema on the skeleton too, I think that should work too. So we'll try that out. And we can actually try that recommendation first if we moved this up here and model scale animation, I think that stays the same. Then when we come over to USD 23.8, now that animates. So that's the recommended fix. It looks like that's how Pixar's assets are set up. So that would be one option. I want to try putting the skeleton binding API, scale binding API on the skeleton to see how that should be an acceptable fix too. Another way that I should have found this is 23.8. I have this build, and if I run USD checker on that arm, it will complain about this scale property, but no schema applied on that. And again, if we move this out of the way, put it on the scale root, which does have the binding, then, nope. Then success. So there was a paper trail of warnings or ways to find out why this was wrong. But of course, you wouldn't expect that from the example from the docs. So that will be fixed. All right, let us get to some coding. So we'll get rid of that one for now. All right. What does ours look like? We've got the indices and the weights. We did that last, I think that was the last thing we did. So we need to do the bind transforms and the rest transforms. And then we can get to the animation. Okay, not this one, not that one, this one. Wait, so we did do the rest and bind transforms. Where are those? Yeah, we have those. Good. So we just need to do the geom transform bindings. This is done until we get to animation. And this mesh needs to be bound to the skeleton. I'm going to point to that skeleton. And we need to do this geom bind transform, which is just going to be identity matrix. And there should be there's a set identity. Let's just make sure I got the right data type, and it wants a matrix 4D actually. So let's take a look at the documentation for that one. What is this default constructor? Leaves the components undefined. Okay. Easy enough. So we'll just do if I understood correctly, it sets it in place. So then we just need to pass that in. I don't remember how I was running this. Was I running this in here? Yeah, I do have the environment set, so I should be able to do. I think I was just running it from here. There we go. There's the geom bind transform. That looks like an identity matrix. Great. Okay, so let's put the binding on the mesh. And we're going to point to, ours is not called model scale. Ours is world arm rig. Yeah. What is the function for this? Create skeleton relationship. I did do this already. Why didn't that show up? Did I miss it? It's there. This should be world arm rig though, if I understood that correctly, because skele is skeleton. And that's where it's pointing to. So our skeleton is called rig. So it's a good thing I came back and looked at this. The skeleton would be that one, right? World arm rig. So all we need to do is replace that with skeleton. Nope, sorry, this one. There we go. Okay, I think we're ready to go to animation. So they put the animation on inside of the skeleton. Let me look at our hierarchy here. So we have mesh next to rig. Okay. So we're going to make a scale animation prim called anim. And we'll go from there. USD scale, animation, define, stage. And we'll do skeleton.getPath, append path. Is it just append? Anim. And we'll catch that object. I don't like all these binding objects. I'll rename them in a moment, but this is going to be the scale. Get prim. Okay. And now we can rename symbol, binding scale. So I'm going to call them the binding and the one that it's bound on, that it's applied to. So binding root, binding mesh, binding scale, if this ever finishes. Can I do two of these at the same time? Will everything implode? Oops. And so like it doesn't want to do anything. Oh, we got mesh. That's good. This one honestly just needs, it's just this one. This was going to be scale. And this one, root. Okay. We got that. I think I understand why root was tagged with binding API. We'll test that out a little bit later. Okay, so we have the animation defined. Now we can go back to our binding scale and create animation source relationship and set the target. All right, I think this coffee's kicking in. Set target to, which one was it? The scale anim, and get the path. Okay, run that. Now we should have animation source. Bam. All right, now let's get those properties in for the animation. We need to specify which joints have animation for this particular animation, and it's just going to be the elbow. And then we're not going to do translation. I think that was just my own creation there. Let's see what the original had. I don't remember if I added translation entirely or if it had static translation defined. Animation. It did have one key or a default value for translations. So we can do that. Okay. So just the joints, translation, rotation, scale. Easy. Skeletal. Create joint adder. And this is going to be an array of tokens, I believe. Set shoulder elbow. Okay, because I think that's what we did here. We just stuck an array in there of strings. And then Skeletal. Create translation adder. And so now we have the attribute. So now we can set it to, I think this is going to be, what did they use here? They used float 3, half 3, and quaternion float. That's interesting that they used. Yeah, I guess that's right. So we're just going to do one value here, GF. I guess it still wants an array, right? Yeah. So we kind of have to do this type of thing here. I'm going to try to do it all in one line. VT. This is float 3. And then I think I can do, as long as these are all floats, let's see what values they used. 002. 0, 0, 2. I think that should work. Yep, that looks happy. That looks like that, except for the time samples. Okay. Next up, rotation. Well, let's do scale. Scale's easier. Create the attribute, get that attribute object back, and then set it to same thing, but it wants half. So float half precision. So there should be an array for that. Half vec3 h array. And then we're going to do ones and call it a day. There it is. I believe these types are defined by the attributes here. So so we have to use this. So that's something that I was thinking about is can I do double precision translation? I'm not sure if that's accepted or not. So something to keep in mind there. Okay, well, does it let me define a type? Let's look at this USD scale animation class. It doesn't look like it. You could do transforms though. and that could be a 4D. So maybe that's the way to go about it. If you need more precision, you do a transform. All right, that's a problem for another day. For now, we're just building a simple arm. Okay, we've got our scale. Next up, rotation, and now we're going to do time samples, so this will be fun. Create rotation attribute. And there's a couple of ways that we could do this. We could have a structure for our animation data so that beforehand, so that it kind of simulates the way that you would probably do this in real life, or you just hard code them. Let's do a dictionary just to simulate that. So we'll do a dictionary. This will allow us to like just get time samples easily instead of a list and trying to find if there's none entries and all that. And this is ordered. And even if it wasn't, that's okay. Okay. So what are we doing here? It has 2 rotations. These are going to be quaternion. So you can imagine you grabbed these quaternion rotations from your DCC that you're creating an exporter for, or connector for. And I suppose we can encode it the same way. Let's see what happens. We'll adjust if we need to. For key in rotation atom, rotation attribute, set, and we want the value, so just do and then time code is a float. So I think we can just put the int straight in and it'll be happy. If not, we'll fix that. So all that is the key. And I think that's all we need to do. So we run it. Yes. Let's look at our USD data types to see if this will. So does it wants an array every time, right? Because this would be for every joint, it wants the rotation. So let's fix that. Will it just work? Got a vector. And what happens if we just do a VT? We're doing a quaternion array, quat-f array from buffer. I don't actually know how to use this function, but if this does what I want, That would be amazing. I really want to use that. We're going to do a slight detour here. We're learning, right? So from buffer, is that what we're trying to use here? Yeah. Okay. Let's go back. Come on, Python code. Ugh, just one. It looks like it's using NumPy. I think it's only for NumPy. My attempt to be lazy on this may end up being more work than... Oh wait, you could do import array. That's not NumPy. From NumPy. What is this Python array? Numeric values, okay, I like this. Float. So we want to do F. How does that work with tuples though? Let's just try it. Let's plug it in. Save this for later in case things fail. Oh, wait, no, I still need that. And this needs to be F. And we're going to import array here just because. And let's see what happens. Psh, must be a real number. All right, one last try here. I probably have to flatten it. List of tuples, blah, blah, blah. Oh, what is this? I don't know what that is. All right. Next time we'll see if we can do something interesting with this. For now, we'll do it the way that I know. So we're doing quad array and GF. Actually, wait, I could just put that list in. I don't know why I troubled myself so much, but that should work. Or did I already try that? I think it needs to be a list. Let's try list And also because these are float, let's try that one first. What was the complaint here? Interesting. And if I make this float, it's not going to make any difference. Nope. Sorry, this is annoying. What if I unpack it? Okay, hold on. I gotta think through this. So we're getting every key, and we're getting a list. Why did this work so much easier here? I did a list of what did I encode here? Sorry, I gotta back this all out. Hey Andrew, welcome. Thanks for joining. I'm stuck on something really simple right now, but hopefully there's something to learn. Okay, so I did. This is correct. No, this is wrong. It encoded this 3 times when I only intended to do 1. I see. So did I try this? Okay, that one worked. Okay, we fixed that. So good deal. Found a bug in the process. So ideally, what I'm trying to do here is the same. I have a list that I'm feeding into a quat for. That's where I missed. No, but quat implies 4. Right, it has 4 components, so that should work. And so what I'm saying is, here is a list with a tuple of 4 components. And just as a sanity check, let's put all of those floats so that it doesn't. Okay. So this isn't pretty, but for value in values, we're going to quats append gf quat F can I unpack this now? Okay, now we should have a list of quads, and hopefully now it's happy. There. Not great, but it's fine. It worked for now. What did it do? Oh, it did it. Yeah. So our list of one quaternion per time sample. Okay. So I'm not happy with this. Obviously, iterating through all of these values, if I had lots and lots of quaternion, lots of rotation time samples, and also lots of joints. More importantly, lots of joints that are being rotated. This is going to be pretty slow. But we'll leave that for now. So I think that's it. We did a prepend here. That's interesting. I guess because I did add instead of set. Let's change that to set just for kicks here. Prepend would be fine. I'm just curious what caused it to do that. Does it want a list or something? Yeah, it wants a list. So now it basically stomped on any other animation source relationship definitions that may have happened on weaker layers. It's now saying I am the end all be all, unless there's a stronger layer that says something else. We could do that just to have a one-to-one with the sample. So we'll do that for the skeleton relationship as well. Okay. Try it again. And that should be it. So now, technically, this should animate. Is it because I didn't set the start and end time codes? Probably. We can do that. At the very beginning, let's set up our stage correctly. Stage dot set start time code. And I think they started at 1 and 10 to 10. They're in centimeters. We'll do this all 1-to-1 here. What does this want? Just a float. So 1. I don't remember how to do this one. I think it's USD 0.1 and set the stage up axis to stage. And there's a token for this. USD tokens Y. Is there a token for this? Is supposed to be 0.1, but is there a token for this? No, probably not. Okay. Okay, reopen. Now you can see this all lit up. Now I can actually use the slider. And that looks correct. This is different from the animation that I've been showing because I added this up translation on the elbow. This one here. So that's why it looks different, but that's actually what it's supposed to be based off of the original example. So that's what we want. Now let's go back to what we opened up with to talk about the changes in 23.8. So I'm going to close that version and I'm going to open up 23.8 USD view. Nope, I just need the arm. Okay, so this animates. Why does it animate? Well, now I'm confused. This was not supposed to animate. I'm on the right version. Quick sanity check here. Yes. Okay, well, I have no idea. This one still doesn't work, right? Well, I must have done something right because my arm works. But why? I didn't intend to fix it yet. Oh, see? So I did. Oh, yes, I did. Because I think the original example was built by hand. Maybe, I don't know. Or no, I'm sorry. It was probably written with code, but it was done in a time when the API was different. It was an older version of USD. But because I'm doing this with a newer version, and I did create a binding API here for the skeleton. This is my skeleton type prim, so that I could use that API for creating the animation source relationship. That added the scale binding API on that rig. So that's why it worked. So this is what I intended, and this is the fix I intended to do. Is the recommendation or the one suggestion was to move this up to the scale root, which is actually kind of probably nicer, because that way you could see what animation is on this character on the skeleton from the top node. Otherwise, you have to dig in deeper. But I just wanted to make sure I understood what was going on here. So we do that. So technically, what I'm not 100% sure on is this scale root. This technically doesn't need the scale binding API. Let's go ahead and open our test arm again. Right, that all works, and I can run USD checker on it. I think it's just test arm. No, where? That should have worked. Oh, I'm in the wrong one. Code with me. There we go. Success. So that validated correctly. So I think that's acceptable. I need to find out. That's something that I need to. I mean, technically, based off of everything that I read, you don't need the scale binding. There's no scale properties on the skeleton root. Let's take a look here. But then you look at this documentation for this basic example. And if you look at the scale root, they say they applied the binding API on the prim. So maybe once you add blend shapes, there might be a good reason. Let's take a look at the character example. I know that one was updated for this release, and we'll end with that. This one. So this one has the scale binding API on the scale root. It does have some, I don't remember what gray means. Gray means no value. So I guess these are implied. And they did put the animation source on this one. So that would be a reason. And the skeleton on this one. So this is probably a more modern way to build this out, is on the scale root, put the animation source and the skeleton target. And that probably makes more sense as where did we put it? We'll need to break this one down more with time. So if we look at our arm, we put the skeleton, we put the skeleton relationship on the mesh. Okay. And then this animation is just referring to those kind of relative joint hierarchy paths. And then for each of these, there's no binding on that, no binding on that, nothing on the X form. Let's do something easier than the face, maybe. Socks sound easy. These X forms have nothing. And you get all the way down to the mesh, and that's where you'll find bind transform, joint indices, joint weights. And then these are all kind of implicitly being shown, I think, because of the binding API. That's a little confusing. And how does it relate the skeleton with the animation? Kind of want to trace through all this and try to understand where, when it encounters a skeleton, how does it piece everything together? I may need to do some more reading on this here. Not quite this one, but probably some of these other documents. All right, I think we're good for today. Andrew, I'm not sure which diff you were thinking might be helpful. Data juggler, I did run it up to flagpole. The issue with your extension not updating, I haven't heard back, so I'll go ahead and ping them and see where they're at. Yeah, I'll let you know as soon as I hear something back. All right, thanks everybody for joining. I hope this was useful to you. I got a little stuck on that VT array stuff. I do want to tinker with that a little bit offline and see if I can find a. Okay, yeah. To try to figure out why mine was working or not, or why my arm was mysteriously animating on the new version. But we got that sorted out. So yeah, I'm gonna play around with the VT array and see if I can figure out how to do see maybe what's different with the quaternion. I feel like that one is different than others that I've worked with. I hope you guys have a great week, and we have a live stream tomorrow. If you haven't checked it out yet, nvidia.com/omnivores. Got our calendar here of stuff that's going on. Another Kit app, Learn With Me, tomorrow, as well as how you can use OpenUSD to solve real world problems. We'll have guests on talking about how they've been using USD. And then engineering design in Omniverse. And on Friday, I'll have a developer office hour as well. That should be on there. Yep. No. All right, I'll need to check to see what happened there. Should be one more on, oh, there it is. September 1st. Yep, I went too far. Cool. All right, see everybody. Bye.